Okay, we are back and better than ever. We are going to talk today about discrete random variables. Random variables, what are they? Well, we can talk more generally if we use variables instead of specific things like results of a coin toss or something like that. A random variable represents in number form the possible outcomes which could occur for some random experience. So this experiment. So this isn't anything much different than what we've been talking about thus far. It's just a way to represent everything with variables. So let's take a look at some more information, the different kind of random variables. What we are talking about here is discrete random variables. And it's very important to know the difference between discrete and continuous. Basically, a discrete random variable, usually represented by the capital letter X, has different possible values. For example, what could those possible values be? This is for any random variable, are the possible values. For example, tossing a coin. The possible values are heads or tails. Okay, so really nothing different. Nice examples here, the number of houses which have a power safety switch, number of bicycles sold, number of defective light bulbs in the purchase order, on and on and on. What distinguishes discrete from continuous? Well, discrete data can be counted. It can be counted. The number of houses, the number of new bicycles, the number of defective light bulbs. It's a certain number. They are discrete and separate. A continuous random variable has to be measured. Okay? In other words, there is no gaps in between. If you have 3 bicycles, there's no such thing as 3.25 bicycles, and don't say, oh, I could cut the bicycle in a quarter. No. If you're counting the number of bicycles, there's 1, 2, 3, 4, 5, or 0, or whatever. But if you're measuring the height of somebody, well, as somebody grows, if they start at 50 centimeters and they go to 250 centimeters, they at some point in time, they have been every single possible height. It's kind of weird to think of, but they have. On this growth spurt. Temperature is another good one. So the upshot here from this page is discrete data is countable, continuous data we measure. And we'll do this chapter, we're just concentrating on discrete. With probability and discrete variables, and actually continuous, we'll get to that later. For any random variable, there is a probability distribution. So let's think about tossing 2 coins. And the random variable x, in this case, is going to represent the number of heads that are tossed. Okay, so cap x, or x, if we toss 2 coins, the possible results are 0 heads, 1 head, or 2 heads. So my random variable x could be 0, 1, or 2. And so the probability distribution is the probability of each of those events occurring. So the probability that we toss no no heads, in other words 2 tails, would be 1/2 times 1/2, or 1/4. And that's where we get the probability that there are no heads is 1 out of 4. 1 head is tossed 1 out of 2. And 2 heads is 1 out of 4. And notice those will always add up to 1. And what does the distribution like? Well, this is called a stick diagram. And for 0, 1/4, for 1, 1/2, or for 2, 1/4. Very simple. Here's a bar graph. So there's a probability distribution. Okay, so just a quick example. Let's say we have a supermarket and it has an inspector is coming along and they are going to check out if a weighing scale is accurate. And they're going to record a Y if it is and an N if it is not. And suppose the random variable X is the number of accurate weighing scales at the supermarket. So X is going to represent the number of accurate weighing scales at the supermarket. List the possible outcomes. Okay, so I'm just going to make a little chart here. Make it nice and neat instead of my usual scribbly stuff. And let's see. Okay, so that's good. We'll go blue here and we'll list our cast registers. There's 3 cast registers, so I said blue and I went green. A, B, and C. And then we'll list our probability that the cast register is working. So we'll start negatively. We could have no, no, no. We could have yes, no, no. Just trying to go systematically here. I'm going to move my Y across the way. No, yes, no. No, no, yes. That doesn't look quite like a Y. What do I want to do? Let's see. So no, yes, yes. And yes, no, yes. I think there's 2 more. What am I missing? Okay, yes, yes, no. And finally, yes, yes, yes. And what's the probability distribution? It's just the number of occurrences where, or the possible outcomes, I'm sorry, where there is, the scale is accurate. Here it's 0. Here is, let's see, 1 yes, 1 yes, 1 yes, 2 yeses, 2 yeses, 2 yeses, and then 3 yeses. So those are the possible outcomes. Let's see. Describe using X the events of there being one accurate scale. Well, that would just be X equal to 1. So we're just really learning notation here. And let's see, what are the events of at least one accurate scale? Well, if I have at least one accurate scale, my random variable could be equal to 1, 2, or 3, because with 2 or 3 there's at least 1, and with 1 there's at least 1. Okay, so that's just the basis for discrete random variables. That's the end of this video. See you next time.